Hello friends, in this video I'd like to solve the following problem from the Swiss Mathematical Olympiad, final round 2012, problem number 2. We wish to find all functions f from the set of real numbers into itself, such that f of x plus 2f of y equals f of twice x plus 8 times y plus 6 for all the real numbers x and y. So my hints for this problem, it's not terribly difficult. First, set x equals 0 and consider both sides as a function of y, of variable y, which is free. And crucially, demonstrate somehow that function is injective. How? Well, remember the crucial property that if a composition of two functions is injective, then the inner function must be injective as well. And then the trick is to put a suitable value of y such that on the right hand side only function of 2x remains, not terribly difficult, and then use injectivity, which means that if f of a equals f of b for some numbers a and b, then injectivity means that arguments a and b must be equal by necessity. So give this problem a try and I will see you in a minute. Okay, so my solution. As I suggested, let's set x to be 0 to start. Set x equals 0. What do we get? We get the following. f of 0 plus 2 times f of y equals f of 0 plus 8 times y plus 6. And now consider both sides as a function of variable y. Notice that the right-hand side is bijective. Why is that? Well, because it's an affine function. It's some number times variable plus some constant. It's an affine function and it's bijective. But I only need injectivity. So let's write that it's injective. So the function on the left hand side also must be injective as well. But let's see, we have a composition of two functions. The outer function is f. The inner function maps y to f of 0 plus 2 times f of y. So this function must be injective as well. Must be injective as well. But let's notice that here we have some constant. Here we also have some constant, which means that function f itself must be injective. Okay, so now we know that our function is injective. And now, let's set a value of x such that this part, 8 times y plus 6, vanishes. It should be pretty clear that this value of y is minus 3 over 4. So let's now set y to be minus 3 over 4. What do we get? Well, on the left hand side, we get f of x plus 2 times f of y, but y is minus 3 over 4, equals 2 times f of x, and 8y plus 6 vanishes, gone. And now, you know what, maybe I will write it in pink, why not? Take note that here we have f and here we have f. Function is injective, which means that arguments of the pink function must be the same. So by injectivity, of f, we have the following. The arguments must be equal, which means that f of x plus 2 times 3 of minus f of minus 3 over 4 equals 2 times x, which means in turn that f of x equals 2x minus f of minus 3 over 4. And let's take a look. This is a constant. Let's call it b. So we know, in other words, that our function must be affine with slope of 2. Yes. And now, crucially, if you are watching my videos about functional equations, you should know what I will do now. Verification. We need to plug this result into our functional equation to verify, is it satisfied? So verification. So again, let's write our equation. Or you know what? Let's write left-hand sides first. It was f of x plus 2 times f of y. And let's put the numbers. F of x is 2x plus b. 2 times f of y is it's 4y plus 2 times b. And now let's write it 2x plus 4y plus 3 times b. And our function doubles the argument and adds b. So we have 4x, 8y, 7b on the left-hand side. At the right-hand side, let's also expand right-hand side. So we have f of 2x plus 8 times y plus 6. Maybe put it lower, why not? And f of 2x is, well, 4x plus b plus 8y plus 6. So it is 4x plus 8y plus b plus 6. And the only possibility, remember, these two quantities should be equal for every x and y, every possible. It happens if and only if these parts are the same, which means that, in fact, b must be equal 1. b must be equal 1, and that means that we have only one solution. So the only solution is function f of x, which equals 2x plus 1. And there are no other solutions. Yes, so as you have seen, injectivity, always, the general rule is, if you have a freestanding variable on the right-hand side, start thinking about surjectivity, injectivity, that kinds of things. And if you have established injectivity, for example, then try to make f of something on the left-hand side and f of something on the right-hand side, because injectivity allows us to get rid of the applications of our function, as I have done in this problem. By injectivity, I have made a suitable substitution, or suitable setting suitable variables, whatever, and I have reduced my problem to the following: f of something on the left-hand side, f of something on the right-hand side. By injectivity, arguments must be the same. Oh yes, thank you for watching. I hope that you were entertained by my talking, and I will see you soon. Goodbye.